Please let me know whether my voice is audible and can you see my presentation. First of all, I would like to welcome you all for the next uh, experiment session or practical session of heat transfer. Great, great, great. Okay, okay. Yeah. So today we are going to understand how to measure the emissivity of any body or any substance. Okay. And for that purpose, we are going to perform one experiment. Okay. So emissivity measurement experiment that we are going to perform. Now, in this particular experiment, our aim is to determine the emissivity of a gray body. Okay, so to get the meaning of a gray body, you should have some theory points. Okay, you should know something about the types of a body according to the radiation properties. Okay, so first body we have discussed, that is nothing but a black body. Okay, the body which absorb all the radiation which are incident on the body surface. Such a body will be considered as black body. Okay, in that case, the black body absorbivity, okay, the property absorbivity is equal to the one, and transmissivity and reflectivity, these two properties are equal to zero in case of a black body. Whereas in case of a white body, the body which transmit or reflect all the radiation which are incident on that particular body surface, such a body will be considered as a white body. Okay, in that case, the property transmissivity of that particular body, it is equal to 1, and absorbability and oh, okay. So in case of a white body, the reflectivity of a body is equal to 1, and the transmissivity and the absorbability, it is equal to 0. Okay. Now further, we have also discussed about the black body, the body which absorb all the incident radiation, and which is having a reflectivity and transmissivity equal to 0. Such a body will be called as the black body. Okay, in that case, in case of a black body, we know that the absorbability of that particular body, it is equal to 1, and according to the Kirchhoff's law, we know that the Kirchhoff law states that the emissivity of body is equal to the absorbability of that particular body. So in case of a black body, if you are getting the absorbability is equal to 1, then in that case the emissivity of that particular body is equal to 1 also. Okay, also equal to 1. Okay, now the next body is nothing but we are focusing on a gray body. The gray body, the body which is having the uniform properties with the entire surface, like the transmissivity, absorbability, and reflectivity. Whatever the properties are there for that particular body, that body is having the uniform properties over the entire surface area. Okay, such a body will be called as a gray body. Okay, the body which is having uniform properties over the entire surface area, then that particular body will be considered as a gray body. Which properties? Absorbability, reflectivity, and transmissivity. So this radiation related properties are uniform over the entire surface, then that particular body will be called as a gray body. Okay, and we know that all the bodies are emitting the radiation in all the directions at all temperatures. Okay, if the body is having the temperature greater than absolute zero degrees Celsius, absolute zero temperature, that is nothing but greater than minus 273 degrees Celsius temperature, then that particular body uh, can emit the radiation. Okay, your body can emit the radiation. So here we are going to discuss about the emissivity. So to understand this emissivity, first of all we should know what is meant by emissive power. Okay, so emissive power means any surface if radiating the energy, then the radiated energy by radiation per unit time per unit area from the surface of the body is called as the emissive power of that particular surface, and it will be symbolically represented as capital E for the general body. And if you are going to consider the emissive power of a black body, in that case you have to give the symbol as capital E suffix B, that is nothing but emissive power of a black body. Okay, Then if you know the emissivity, if you know the emissive power of a black body also, and if you know the emissivity of a general body for the same material, then it will be easy to calculate the emissivity of that particular gray body. Okay, it will, what you know, if you know the emissivity, if you know the emissive power of a black body, and if you know the emissive power of a normal body or a gray body, okay, then we can calculate the emissivity of gray body. Then we can calculate the emissivity of a gray body. So how to calculate the emissivity of a gray body? So the emissivity of the surface is the ratio of the emissive power of the surface to the emissive power of a black surface at the same temperature, okay. So let us understand the meaning of this particular sentence. Okay, the sentence meaning is is based on, or it is the basic for the performance, okay, experiment performance. Okay, what is the emissivity? Emissivity is the is the ratio of is the ratio of the emissive power of the surface. Okay, so general surface we are going to consider, and the emissive power of that particular general surface. Okay, and that how to determine that particular emissive power of that particular general surface, that is also important. And then second body we are going to consider, which is having the same surface, okay, but the surface is covered up with the black color. Okay, same material we are going to consider, but the surface we are going to cover with a black color. So that body will be act as a black body. That particular body will act as a black body, and we are going to measure the emissive powers of these two surfaces. Okay, these two surfaces. So that is nothing but the emissive power of a black surface and emissive power of a gray surface. Okay, and that will provide you both the emissive powers. Okay, so our definition is fulfilled. Now measurement is more important. Okay, how to measure the emissive power, and what, at what condition we have to consider that this is the emissive power of that particular body. So for that reason they have specifically mentioned that at the same temperature, okay, at the same temperature, both surfaces, black surface and the gray surface, should have the same temperature. Okay, and they are exchanging the heat in between. So that is the basic condition. What, both surfaces having the same temperature, both surfaces are having the same temperature. In that case, whatever the emissive power we are getting for the black surface and to that of a gray surface, the ratio of these two emissive powers will provide you the emissive power of that particular gray surface, emissive power of that particular gray surface. Okay, understand the meaning of this particular sentence. So emissivity is equal to emissive power of a gray surface, that is nothing but capital E, divided by emissive power of a black surface, emissive power of a black surface, that is nothing but capital E suffix B. Okay, capital E suffix B. Okay, so we know that for black body absorbability is equal to 1, and according to the knowledge of Kirchhoff's law, emissivity of black body becomes unity. Okay, we know that according to the Kirchhoff's law, emissivity is equal to the absorbability. So for black body, according to our black body definition, the absorbability is equal to 1. So by default, the emissivity of black body, it is also equal to 1. Okay, so we are going to perform the experiment on this particular setup. Okay, so this is the closed compartment. Okay, not completely closed. Some air ventilations are provided over that particular compartment, and the two discs are provided. Now here the disc 1, okay, this arrangement is vertical one. So here you can see that it is the top view. Okay, let us say this is the top view. Okay, and you are watching this particular setup from the top side. So the first disc, okay, so this is the first disc is there. Okay, the material we are considering in the form of in the geometry of disc. Okay, and on this particular disc, the thermocouple, one thermocouple is provided. Now here three thermocouples are provided, but in our actual experiment only one thermocouple is provided to measure the temperature of black surface, okay, to measure the temperature of a black surface, and heater is connected to that particular black surface, okay, heater is connected to that particular black surface. Then second plate is similar fashion. We are considering the same geometry plate having the same properties, but the surface is not coated with black color. Okay, so that particular plate will be considered as a gray plate. Okay, which is having the radiation properties uniform over the entire surface. Okay, radiation properties uniform over the entire surface. So that particular plate, second plate, will be considered as a test plate. Okay, and one heater is also connected to that particular plate to increase the temperature of a plate. Okay, now these two bodies will continuously exchange the heat with each other. Both are having that higher temperature than the absolute zero temperature. So both the bodies will continuously exchange the heat with each other, as we know that according to our normal definition or basic knowledge about the radiation is that every body emits the radiation in every direction for all the temperature, which is having the temperature greater than the absolute zero temperature. Okay, so the black body or black plate is also having the temperature greater than the absolute zero temperature, and the gray plate or the test plate is also having the temperature greater than the absolute zero temperature. So both the bodies will emit the radiation, also this both the bodies will absorb the radiation. Okay, doesn't matter what is the initial temperature for both the bodies, but both the bodies emit the radiation. Okay, both are having the emissivity, some kind of emissivity, and both the bodies will absorb the radiation. Okay, both the bodies will absorb the radiation, and after some time, okay, after some time, both bodies will attain the equilibrium with each other. Okay, that is nothing but what the black body temperature or black plate temperature will be equal to the test plate temperature or gray body temperature. Okay, so when we will achieve this particular temperature, both are having the same temperature, then we will take the final reading. Okay, and to take the readings, you are having the temperature indicator. Okay, which will measure the black body temperature and test plate temperature. Okay, black plate temperature and test plate temperature. And also one more temperature we require, that is nothing but this particular compartment temperature or the surrounding temperature for the calculation purpose. So you have three thermocouples which are placement is like that way. First thermocouple is placed on a black plate which will measure the black plate temperature, and second thermocouple is placed on a test plate which will measure the test plate temperature. Okay, and third thermocouple will measure the compartment or the environment temperature. Okay, third thermocouple will measure the compartment or we can say that the environment temperature. Okay, so these three temperature readings we required for the calculation purpose, and we will get this temperature reading by using the temperature indicator. Okay, second thing we required, that is nothing but the input heat supply for these two plates. Okay, input heat supply for these two plates, and for that vary the input heat supply to the heater. Two dimmer stats are provided. Okay, dimmer stat 1 or B type of a dimmer stat or B the dimmer stat is used for the black body to vary the heat input for the black body, and the test type of dimmer stat, or we can say the T type of a nomenclature we have provided for the test plate dimmer stat, and that will vary the heater input for the test plate. Okay, and how to check that, how much heat input or the energy is provided to this two plates. So for getting that particular readings or heat supply to the heater, we required the ammeter and voltmeter. Okay, so ammeter will check the current. Okay, or it will provide you the current reading, and voltmeter will provide you the voltage reading. Okay, and we know that voltage multiplied by current will provide you the heat supplied or heat generated by the heater. Okay, so V1 in that case, two knobs are provided to vary or to shift the readings from black plate to the test plate. Okay, so the switches, by using the switches we can take the readings for the ammeter and voltmeter for black plate and test plate. Okay, once you get the readings, once you achieve the steady state temperature or the equilibrium temperature, okay, black plate temperature is equal to the test plate temperature. In that case, we have to consider the ammeter reading, voltmeter reading, and surrounding ambient temperature. Okay, so that readings we required for the calculation purpose. Okay, and most important thing is nothing but for calculation purpose you require some specification. Okay, so first requirement is that whatever the surface area we are going to consider for the black plate, same surface area we are going to consider for the test plate. So for that reason, test plate diameter should be equal to the black plate diameter. Okay, so phi, that is nothing but diameter of a test plate, which is equal to 165 mm, and black plate diameter also we are going to consider as 165 mm. Okay, then the nichrome strip uh, mica sheet sandwiched between two mica sheets, we can say that that is the specification of heater. Nichrome type of a heater is used, and thermostat is range is in between 0 to 2 ampere and up to 260 volt, and second thermostat is also having the same uh, specifications. Okay, so I will not consider that specification for the write-up purpose. Just one specification is more important, that the diameter of that particular plate, and we are going to consider the same diameter for the both the plates, for black plate also and for the test plate also. Okay, so geometry we are going to consider as the same one. Okay, then we have to take the observations, observation table in this manner. So for black plate, we are going to consider the input voltage, then input current. These two readings we will take, and the surface temperature of black plate. Okay, that three readings we will take for the black plate, and three readings similar fashion. The voltage, input voltage for the heat test plate, that is nothing but V2, and input current for the heater of a test plate, that is nothing but I2, that will require to calculate the heat input for the test plate. And the third reading is about the test plate temperature. Okay, so that will be symbolically represented as T suffix S. And the final temperature reading we have to consider if this TB and TS are equal, okay, near about equal, these two temperatures are equal, then in that case we have to consider the temperature of enclosure. Okay, that will be the ambient air temperature or surrounding environment temperature, and that is equal to T suffix A. Okay, so once you achieve the equilibrium and steady state, then we can perform the calculations. Okay, so calculation, for calculation purpose, first of all, the heat supply we have to calculate. Heat input to the black plate will be calculated as the voltage input for the heater 1 or the black plate heater multiplied by current input to that particular black plate heater. And if once you calculate the Q suffix B, okay, then you can use the Stefan-Boltzmann law, that is nothing but the heat transfer rate per unit area is directly proportional to the temperature difference between the surface and the surrounding. Okay, or we can say that in case of radiation, the radiation energy emitted by the surface per unit area is directly proportional to the absolute temperature of that particular body. Okay, of that particular body. Now here we are having we are considering that the radiation emitted by the body uh, 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 which will be equal to the heat input to that particular body. Okay, heat or how much amount of temperature we have increased from the surrounding temperature. Okay, so that much amount of radiation will be emitted by that particular body. So according to the Stefan-Boltzmann law, the Q suffix B amount of heat is supplied to that particular body. Okay, and which is equal to sigma multiplied by E suffix B multiplied by A multiplied by T suffix B raised to 4 minus T suffix A raised to 4. Okay, where the sigma is Stefan-Boltzmann constant, and we know the constant value as 5.67 into 10 raised to minus 8 watt per meter square Kelvin raised to 4. Okay, then this E suffix B, that is the emissive power of a black plate, we have to calculate. Then surface area, for the calculation of a surface area, we have a diameter, so we can calculate that particular diameter. Then once we achieve the equilibrium temperature, then we will consider that temperature as T suffix B in absolute temperature, that is nothing but in Kelvin temperature. Okay, so whatever the temperature we are getting, it will be in a degree Celsius. Then we will convert that temperature in Kelvin format, and then we will consider this temperature for the calculation purpose. Then T suffix A is nothing but the enclosure temperature or the surrounding temperature. So this particular formula will provide you the emissive power of a black body, okay, or the black plate, emissive power of a black plate. So once you calculate, we have the emissive power of a black plate. Similar fashion, we are going to calculate the emissive power of the test plate or the gray body. Okay, so test plate heater input is Q suffix S, and which is equal to the V2 multiplied by I2. Okay, V2 multiplied by I2. And further, according to the Stephen Boltzmann law, we can calculate Q suffix S, that is the heat supplied to the test plate, which is equal to sigma multiplied by E suffix S multiplied by A multiplied by inside the bracket T suffix S raised to 4 minus T suffix A raised to 4, where this T suffix S is nothing but the temperature of the test plate, and E suffix S is the emissive power of a test plate. Okay, so from this particular equation we will get the emissive power of a test plate, and from this equation we will get the emissive power of a black plate. Okay, and the finally our aim is to determine the emissivity of the test plate. So finally you can calculate the emissivity of a test plate as eta is equal to emissivity of test plate divided by emissivity of a black plate. Okay, so I'll write the equation. Final output will be in the format eta is equal to emissivity of a test plate. I will write E suffix S divided by E suffix B. Okay, and that will provide you the emissivity of that particular gray body. Okay, that particular gray body. Is there any question, any doubt? Is there any question, any doubt? Also, we can also use another formula to calculate this particular emissivity of a gray body. Okay, so for considering this, we can consider once again this formula as Q suffix B minus Q suffix S. So net heat exchange between the two bodies. Okay, net heat exchange between the two bodies, which is equal to, inside the bracket I will consider emissivity of a black body. Okay, emissivity of a black body. So E suffix B, that will be the emissivity of a black body, minus emissivity of a gray body. I will consider only eta. Okay, emissivity of a gray body. Okay, multiply by sigma multiply by area and multiply by Ts minus or Tb minus Ts raised to 4. Okay, or one of the temperature. Okay, Tb minus Ta raised to 4. Okay, because Ts and Tb are equal, then one of the temperature you can consider Ts minus Ts raised to 4 minus Ta raised to 4, or Tb raised to 4 minus Ts raised to 4. So how to use this formula? Now in this particular formula, after observation also, we are having two unknowns, that is nothing but emissive power of a black body and emissive power of a gray body, that is E suffix B and eta suffix B is the emissive power of a black body and eta is the emissive power of a gray body. But according to our Kirchhoff's law and according to our assumption, we know that emissivity for the black body is always equal to 1. So one unknown we have crack, that is nothing but emissivity of black body is equal to 1. Then in this particular equation also only one unknown will remain, that is nothing but emissivity of a gray body. Okay, so just put up emissivity of a black body is equal to 1, and other things we have observed, that is q suffix b we can calculate by using the input power for the black body heater, and q suffix s we can calculate by using the input power for the test body. Okay, and further TB and TA are the observations, and sigma is the constant, Stephen Boltzmann constant, and as we know the diameter of the plate, then you can calculate the area also. So only one unknown is there, that is nothing but emissivity for the gray body, so that can be calculated by using this particular formula. So any one methodology you can consider for the calculation purpose, and you can perform the calculation, or by using two methods also you can perform a calculation, and check, you can also check the difference between the two methodologies. Okay, so by using this methodology what will be your emissivity, and by using this particular formula what will be your emissivity. Okay, you can check that. Okay, so the final result will be the emissivity of a gray body is dash dash. Okay, so you have to calculate that particular final result, and that will be your final output. Okay, so is there any question, any doubt in this particular experimentation? Now I will go for the uh, demo of the actual performance. So if you have any doubt, any question in the theory part, then you can ask now only. Okay, if you don't have any question, then you just draw this table, which will useful to you to take the readings, final readings. Actually, the readings, to achieve the readings, some trial and error method is required to maintain the plate temperature and test plate temperature, and to achieve the steady state near about 1.5 hour is required. So initially I have started this instrument, and just we have to conduct the we have to take the readings, and we have to perform the experiment. Okay, so if you don't have any doubt and you have taken all the readings, then uh, I will stop presentation from here, and I will present from the HT lab. Okay. Okay. Uh, this is our instrument. You can see here. Okay. In this particular closed compartment, we have placed on the side on the black surface. Okay, black surface or black coated plate, and this is the gray plate. Okay, gray plate. Wait for 1 minute. And here you can see on this side. So two thermostats are provided on thermostat B, okay, and thermostat T. So thermostat B, okay. So thermostat B will use to measure or to change the heat input for the black body or black plate heater, okay, and thermostat T will be used to change or vary the heat input or the power input. Obviously, the electric input will be varied, and accordingly, the heat input will be varied for the test plate. Okay, by using the thermostat T. Okay, let us discuss about this particular plate. So here you can see. So this. Huh? Yes. This thermostat or the electric input is directly provided to these heaters. Okay, so these are the heaters. Okay, this wire you can see, and on the back side, this is the thermocouple, and these are the heater wire. On the back side of that particular black plate, the heater is connected. Okay, so this heater plates wires are there, and then on this side also for the gray body, one heater is connected, and these are the wires for the heaters. Okay, and the heater will convert the electrical energy into heat energy. Okay, so two thermocouples are connected. So here you can see that this is one thermocouple which is connected to the gray body, and one thermocouple is connected to the black body. That will measure the temperature of a black body and the gray body. Okay, so that will be the input, and the third thermocouple is placed over here. Okay, so third thermocouple which will measure the compartment temperature or enclosure temperature. Okay, compartment temperature or enclosure ambient or environment temperature which is surrounding to this particular two plates. Okay, now further we required to maintain the temperature of both the plates equal. Okay, or we have to achieve the temperature of both the plates equal. Okay, so for that purpose we have to use the trial and error method. Means what? We have to vary the thermostat, and we have to vary the voltage. Okay, and accordingly the heat input will get varied, which is supplied to the plate. Okay, first of all you have to make the arrangement, or you have to take the voltage reading first of all. Okay, so consider that these are the two knobs. Okay, so which are used to shift the voltage and ammeter readings. Now it is now ammeter and the voltmeter does not show any reading. Okay, so because both are off now. Okay, and if I shift this in the upward side, both the knobs, if I shift in the upward side. Okay, so first of all I shift this, then I will shift this. Okay, now it is showing the voltage and current reading for the black surface. Okay, so now voltage, first of all you have to make that assure that at what voltage of black surface you want to take the reading. So first of all fix that. So now according to me the voltage is fluctuating in between 50 to 56. So we can consider that we have fixed this particular voltage for the black body heater at a 55 voltmeter, and accordingly the ammeter reading you will get as 0.129. Okay, now if you check that whether how much temperature you are getting for this particular black plate. So T1, okay, T1 will measure the black body temperature. Okay, so consider that this is the position of a T1. Okay, then it will measure the black body temperature. So now it is equal to the 59 degrees Celsius. And if you shift, Okay, so 59 degrees Celsius. Now if you want to take the voltage reading and the current reading, and uh, uh, in that case you have to shift this particular knob, okay, in the downside. So you can take the temperature voltage reading and ammeter reading for the test plate. Okay, now it is showing, it is at the middle position, so it is showing the 00 readings. So I will shift this to the downward side. First of all, I will shift the voltage uh, knob and then current knob. Okay, now the voltage or the power supply for the test plate is provided near about voltage is 38 volt and the current is 0.113. Okay, so it is required that if you want to achieve the equilibrium state for both the plates, then in that case for the plate you have to provide the less heat input as compared to the black plate. Okay, as compared to the black plate, because if you increase the heat input for the test plate, then its temperature goes on increasing, because emissivity of a black plate is high, and that will transfer the heat to the white plate also. And white plate is also or the gray plate is also generating the heat. So both, because of these two combination, the temperature of the gray body will get increases. Okay, will get increases. So because of that you have to use the trial and error method to achieve the equilibrium between two plates. Okay, equilibrium between two plates. So here I'm getting the voltage reading as 38 and current reading as 0.113, and the T2 will provide you, second thermocouple will provide you the temperature of the test plate. Okay, the temperature of test plate. Now if you check that initially also for the black body I'm getting 59 temperature, and for the test plate also I'm getting the 59 temperature. So we have done some trial and error method. So trial and error method is required at what voltage you get the equilibrium. So for that you need to perform the trial and error method. So then now we are getting the both the readings. Okay, for V1, V2, I1, I2, and T1, T2. This both the readings are equal. This temperature, two temperatures are equal. Then we can take the voltage readings. Okay, 38 and 0.113. Okay, and initial reading we'll check. Okay, so 59 and ambient air temperature. Ambient okay, ambient air reading 40 degrees Celsius. Okay, 40, 59. Okay, and this is also okay, 60. Both are having 60 temperature. Okay, so consider 60, 60 as T1, T2, or TB and okay, and 40. Okay, ambient air temperature 40. Okay, so that's happening. Okay, you take anyone. Prajwal is there. Prajwal, Musre, anybody else? Camera फिर कोना बगल गेलो camera. Okay, who is rhythm? Prajwal. You take reading, Prajwal, and all other students also can take the readings. Okay. So first of all, we'll start from black body, that is V1 and I1. So take V1 as 55. Okay. V1 as 55 and I1 as 0.113 or 0.129. Okay, I1 as 0.129, and TB as 60 degrees Celsius. Temperature of a black body at 60 degrees Celsius. Okay, then we will shift this to the test readings. Okay, now V2, you can take V2 as 38 and I2 as 0.111 or 0.11, right, 0.111. Then surface temperature, the plate temperature 60. Okay, plate temperature 60, T2 on a T suffix S. Okay, test plate temperature 60, and the last reading we required the ambient air temperature. Okay, surrounding temperature or environment temperature, and it is equal to 41. 41. Okay, so we have observations now, and on that basis we can perform the calculations, and we can calculate the emissivity for the gray body. We can calculate the emissivity for the gray body. Okay, so uh, if you have any doubt, any question in this particular performance, then you can ask. Is there any doubt, any question? So the performance experiments are over. Okay, performance experiments are over. Now two programs you required to write. Okay, for the submission purpose. Just now you have learned the Python programming. Okay, so take any experiment, any two experiments, and you write the Python program for that particular experiments, or else I will share the C program, one of the C program. Okay, and Java program also. You can perform that also. That will be the best practice for you. Just you have learned the Python programming, then you have the knowledge of C and C++. So any language you consider, and you can perform the program, and please, you can check that whether you are getting the same answer after putting the values whatever we have taken for in the observation table. By taking that particular values, whether you are getting the thermal conductivity same, or the natural convection. In natural convection, if you are going to consider the natural convection, in that the natural convection values you have to consider, and whether it is providing the accurate result or not. Okay, so that you have to compare with the our actual performance, and that will be your seventh and eighth experiment. Okay, that will be your seventh and eighth experiment. Now performance part is over. 6 experiments we have performed up till now, and the performance part is over. About the heat transfer subject practicals, and two practicals is about assignments on any language. Okay, Python, then C or C++ or Java. So you take any two experiments, and you have to write the program for that particular two experiments for the calculation. Okay, calculation programs. Okay, so just I suggest that just you have learned the Python programming, so you can practice how to apply the Python program for the calculation of heat transfer practicals. Okay, so I will stop presentation from here, and go to my PC for next part, that is calculation part. Okay, is there any doubt, any question? Then you can ask in performance. No? Okay. Prajwal, tell me the values of observation. Please let me know first of all whether my screen is visible to you. Whether my screen is visible.
Yes, sir.
Okay. So tell me value V1 55, right?
55.
I1
0.129.
0.129. Okay. Then TB black body temperature
60
60.
degree.
Okay. V2
38.
38. I2
0.111.
0.111 and test plate surface temperature 60.
60 degree.
Okay, and enclosure temperature, ambient air temperature or surrounding temperature 40,
1.
41, right? Okay, so the calculation part. First of all, we have to calculate QB. Okay, QB is equal to V1 multiplied by I1, 55 multiplied by, okay, I1 is 0.129. Do calculation and please let me know the QB. Okay, please check 7.095. Okay.
Yes, sir.
Okay. So then QB is equal to, okay, we have to calculate the emissive power of a black body. So QB we have just calculated 7.095 watt. Sigma value is 5.67 into 10 to the power minus 8. 10 to the power minus 8. Okay. Then EB is unknown. So multiply by EB. Now area we have to calculate first of all. Now here we require the area. So area, how to calculate area for the disk surface area. Now disk is having double side, okay, front side and back side. So normally the one side area will be equal to pi multiply by d square divided by 4. Okay, this is the normal area. But we are having two sides of a disk. So we have to multiply with 2. Okay, we have to multiply with 2 and it should be equal to pi d square divided by 2. Okay, because disk is having front side and back side. So we can say that its area will be equal to pi d square divided by 2. So d is equal to 167 mm, 165 mm. Okay, so pi multiply by inside bracket 165 multiply by 10 to the power minus 3 bracket square. Okay, or you can take 0.165 bracket square directly divided by 2. Do calculation and find out the area. Find out the area. And this area is same for both the plate. Okay, as both are having same geometry and same dimensions. 0.0427. Okay, 0.0427. It will be in a meter square. Okay, so meter square. Okay, it will be in a meter square. Now you can put up these values in this formula to calculate E suffix B. So we have put up and area value is known. Now multiply by 0.0427 multiply by TB. How much TB? 60 raised to 4 and minus 41. 41 raised to 4. Okay. So do calculation and calculate emissive power for the black body. Do calculation and please let me know the emissive power for the black body. How much it is? Oh, sorry, one mistake from my side. Actually, we have to take the temperature in a Kelvin. You have to suggest me like that. I made a mistake. So 60 plus 273. How much it is? 230
333.
raised to 4. Okay. And 41. 41 plus 270, 274 plus 40. 214 raised to 4. Okay. Same you have to use for the calculation. Now do calculation and let me know your answer. 3.44 emissive power of a black body, right? Yes, sir.
Yes, sir.
Okay. So emissive power of a black body is equal to, please check others also if you are getting the same answer or not. Emissive power of a black body. So it will be watt per meter square. Now second, we have to do the calculation for, same calculation for the plate. Okay, Q suffix x, V2. V2 is equal to 38. 38 multiply by 0.111. Do calculation and please let me know this value. Q suffix s. Whether everyone getting this Q, E suffix B, emissive power of a black body is equal to 3.44. Then, okay, so Q suffix s to 4.18. How come 4.18? 4.18, right? Or 3.18? 4.21. Okay. 4.21. Okay. So Q suffix is 4.21 and it will be watt per meter square only. Q suffix S. No, only that. Then put up the values. So Q suffix S is equal to sigma multiply by E suffix S multiply by area multiply by TS raised to 4 minus TA raised to 4. So put your values in this particular equation. 4.21. 5.67 into E suffix S, which is equal to multiply by 0.04 area तो वैसे ही रहेगा. Now once again 233 raised to 4 and minus 214 only because TS and TB are the same. Okay, so do calculation and determine E suffix S. E suffix S. E suffix S is equal to. Please let me know E suffix S. Please let me know the E suffix S value. That is uh, emissive power of a test surface. 2.04. Okay, 2.04. Right? 2.04 E suffix S. Then calculate emissive power, emissivity. Emissivity. So E suffix S is 2.04 and E suffix B is 3.44. So how much it is equal to? Which is equal to 0.593. Okay, 0.593. Oh, double 0.593. Okay, so that is calculation. We have got the emissivity for the gray body. So similarly, if you use this formula, just put up the values in this formula and you will get by emissivity by another method. QB 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 value is 7.095. 7.095 minus QS 4.21. 4.21 equal to. Now here we have to consider the emissivity for black body as 1 minus and we have to calculate emissivity for gray body. So eta we have remain as it is. Okay. But another method we are using, so we have to calculate eta.
Values.
Multiply by 5.67 into 10 to the power minus 8 and 0.0427 area we are taking as it is. No, all the things I will take as it is. See, and I will remove E suffix S from here. So 0.04 multiply. Okay. And now you determine how much you are getting. Eta, this eta value. Okay, 0.402. This by using this formula. Yeah, sir. Right?
Yes, sir.
By using this formula, you are getting 0.402. Okay. And right now, black body. Okay, 330. Sorry. Everywhere I am taking 233 only. Uh, have done the correction properly? Have you calculated it properly? Because I made a mistake. Instead of 333, I am taking 233. 314. This should be 314. 214. So, it become 3145. So we go to have taken this as 313 and 314 after adding 273 because I made a mistake that instead of 233 I have 333 I have written 233 and instead of 314 I have written 214. So have you taken the same values and calculated these things or you are also taking 233 and 214?
Yes, sir.
What you have done, yes sir?
214 I have taken.
214 you have taken. Oh,
213.
anybody has calculated by taking 333 and 314? Anybody else who has done it properly? Okay, once again perform this now. Calculation part. Calculate E suffix B first of all. So
1.13.
1.137.
7. 137.
137. Okay, check it once again now. Then okay, E suffix B 1.137 right now. Okay, वरती जो कुठं नाही इथं चुकलं E suffix B. Okay, so Q suffix X right आहे. Now E suffix S. How much you are getting E suffix S?
0.675.
0.675.
5.
Okay. And now calculate this emissivity. So 0.675 divided by 1.137.
0.593.
0.593. Right? ठीक आहे ते. बरोबर ना? Okay. Then do calculation for this now. 7.095 minus 4.21. Okay, here I will write by using another formula. Now you have to calculate the emissivity for the gray body by using another formula.
0.729.
Okay, 0.729, right?
Yes, sir.
So why it is different than actual calculation? Because in this case we are considering the emissive power for a black body as 1, okay, but it is near about 1. Means what? If 0.99 emissivity, okay, sorry, emissivity for black body we are considering 1, but maybe it will be 0.98, 97, 95. Okay, so you can also check by using this particular formula. You can use the trial and error method for the emissive power of a black body. Okay, so if you check this, because this is the actual final answer, if you put this answer in this particular bracket, in this particular formula, and you check the trial and error method, and you find out, you can get the actual value for the emissive power of a black body. So by using this formula also we can determine the emissivity for the gray body, okay, for the gray body, and that will be the somewhat difference. How much it is we are getting? 0.97, okay, near about 0.25 difference we are getting, and that because of this assumption that is nothing but emissivity for a black body is equal to 1. Okay, so by using these two methodologies, you can calculate the emissivity for the gray bodies. Okay, by using these two formulas. So this is about the experiment number 6. Okay. Now let us say that you have to write the experiment number 7 and experiment number 8. Okay, 7 and 8. So by your own, you have to write that particular experiment. So if you are having the laptop, then you directly perform this particular experiment on Python programming. So you can take the inputs as, okay. So you can provide the nomenclature as V1, I1, TB, V2, I2, TS, and TA. This will be your, we can say that, variables, okay. And you have to define in the program that Q1 or QB, okay. QB is equal to V1 multiplied by I1. Then QS is equal to V2 multiplied by I2. Okay. Then after calculation that Q1 and Q2, or QB and QS, then you have to define this particular formula. Okay, or you can directly define the formula for emissive power of a black body. Okay, and you have to define the formula for the emissive power of a gray body, and finally you have to define the formula for emissivity. Okay, formula for emissivity. Okay, after defining these particular formulas, okay, after defining these particular formulas, and also you required the formula for A. So after defining these particular formulas in the program, you can directly put up the input values. Okay, so the program should ask you that what is the value of I. Okay, I, then you I1, I2, V1, V2. Okay, then D value, that is diameter value. After putting all this, and then TS value, then TA value, and TB value. So after putting this all value as the input values, so program should directly show you the answer, and that particular answer equal to 0.593. So that is the logic behind the program. Okay, that is the logic behind the program. Okay, so you have to define all the variables in the program, then all the formulas in the program. Then program should ask you the input values, that is voltage, current, then the diameter, then the surface temperature for black body, then surface temperature for the ambient air, and whatever the calculation that will be done by the program, and you will get directly the answer or the result as emissivity is equal to 0.593. Okay, 0.593. This is the logic behind the programs. Okay, so how to perform that, in which language you want to perform that, it's your matter. Okay, So finally, if it is possible for you to take the printouts for that particular program and for the result, okay, so you can take the printouts, and that will be the experiment for you, or that will be the assignment for you, okay. And in similar fashion, I have given the example for this experiment, okay. So one more experiment in such a fashion you have to perform for the program, okay. You have to perform the program for one more experiment. So two experiments you have to perform the programs, and you can take out the printouts for the programs and the results after providing the input, whatever the result you are getting, by considering the observation values that we have considered for the actual experimentation. That values you have to consider for the input values, and you have to get the result, okay. So two printouts are required for the submission. That is, one is the program printout, what program you have performed, and second one is the result printout, okay. So what result you are getting, final answer, okay. Or else, if you don't have this particular facility, printout facility, or one can say that the program performance facility, okay. So in that case, I will provide you uh, the C programs, whatever I have, or we are having in our lab manuals, okay. So very long programs are there, so I will provide that. You just write down that programs on one page, okay, by hands, and you can submit that programs, okay. You can submit that write up part. If you don't have the facility of computers, printer, okay, if the printer is not available, no problem. If you convert that into notepad, okay, whatever your program and result in a notepad, and if you convert that notepad into PDF format, then also no issue, okay, directly on online. If you don't want to take the printout, then also this is also another method to do that thing. Or else, third option with you, that is nothing but you write down whatever program I will provide you, but that will not enhance your knowledge, okay, getting my point. So that will not enhance your knowledge. In few weeks or in few months, TCS will uh, conduct the interviews, or mm, this particular aptitude test and program test will be there. And if in interview it will be asked that if you have performed the Python program, where you applied this knowledge in your curriculum. So one point with you, that you have applied this knowledge for the calculations of to develop the program for the calculations of heat transfer subject. So that will be extra advantage to you, okay. So in this fashion, and if you perform that, then you will be able to explain that particular knowledge in front of a interviewer, or that particular logic in front of an interviewer, okay. Getting my point, okay. So that will be the assignment for you. I will share this experiment number 6, experiment number 7, and experiment number 8, okay. 7 is this much only, 6 is this much only. Seventh and eighth experiment will be your programs, okay. Programs, that write up part I will share. Those are those does not have the facility to perform the programs, they can directly write down the programs on papers, okay, and you can submit that things. And if you have facility, I suggest that go for performance, okay. You prepare your logic, develop your logic by using Python programming, or else C programming, or else C++ programming, or else Java programming. Any logic, any language you can use, and you can get that particular results, okay. So uh, now the practicals are over for both the divisions, okay. And for B division, uh, for B division, complete syllabus is over. For A division, 1 point is required. 1 point is remaining. That is nothing but radiation shield. It required 2 hours. Okay, it will require 2 hours, and that particular point is also important. And the problems on that particular point asked in gate examination also, and for our normal examination also. So that point is important from radiation chapter. 1 point is remaining for A division, that is radiation shield. and that will I will cover in the next lecture for A division. And for B division, the complete syllabus is over. For A division, the practical part is over, and 2 hours are required to cover the radiation shield point, and that will I will cover in the tomorrow's lecture. Okay, and this particular write-up part, all 5 experiment write-up part I have shared in WhatsApp. Also, all 5 experiment write-up part is available in study material. All the lecture links are available in a study material. All the class notes are available in a study material. You go check. If you don't, if you are not getting anything, you watch videos. Videos are uploaded on YouTube. Each and every video is uploaded in YouTube. So you go check, clear your doubts, and you can attend the oral examination. Okay. So shortly, within 10 days, within 5 to 6 days, the external oral will be uh, enforced to you, and you have to uh, attend the oral also. So in that case, if you have any doubt, you go to the study material, check study material, then check uh, the video lectures. Point wise, I have given the video lectures. You can check that also. Very nice manner. I have provided video lectures over there. Then the books, PDF books are available. Uh, 2 PDF books I have uploaded in first chapter. So you can take the help of that PDF books also. So everything with you. Okay. Just you have to study it properly. Okay. So thank you very much for attending this experimental session. Then you can put up your roll numbers in the chat box, and you can leave this particular meeting. Okay.
झालं ना आता की रेडिएशन शिल्ड कधी घेणार आहे?
उद्या घेतो. कसं माहिती आहे, हुरहुर राहतील. पोरांना काय वाटत नाही, आपल्याला वाटतं राहिले. माहिती. Remaining student, put up your roll numbers. I'm going to close this particular meeting.